Well, good day everyone. I have something for a teardown today, or to borrow Ed's little title, an equipment autopsy. Thank you very much, Ed, aka Aussie 50. Here I have an ABB VF drive. This one is a failed unit. There are the specs on it. I'm not going to read them out. This thing isn't really that old. It's 2008. It's June 2008. Obviously it's DIN, mount kind of thing. And it's had something very bad go wrong. As you can see, it's gotten very hot. And even though this is being shot through the camera on the wide angle lens, with the wide angle lens, you can see that that's not supposed to be like that. It's all distorted and it's just been very, very hot. I have no bloody idea why. Yeah, I don't know anything about this drive. It's just something that I was given just for YouTube, so it's obviously never going to be repaired. Like, the fact is, I believe they use IGBT technology, which stands for insulated gate bipolar technology. I know a little bit about how they work, but I don't know a lot. So what I'm going to do is pull this apart, and then I'll get some type numbers out of it, and I'll start looking up data sheets, and I'm going to post type numbers to whatever I think is interesting in the description for the video. So this screwdriver gives you a good idea, or a small amount of an idea of how warped everything is. It's just, it's gotten so hot. Yeah, it's just gotten very, very hot. So this thing's not really held together by much. It's it's got some screws here which are obviously, there to connect cables, maybe? I don't know. One's EMC and maybe EMC's earth metal chassis or something, or I'm not really sure. I don't know a lot about VF drives. I know what they do and roughly how they work. What a VF drive is, in case you don't know, it's a variable frequency drive, and it's basically for three-phase equipment. And just looking at this, probably not going to be able to see it because of the camera angle, but anyway, we've got terminals which are output to the motor, which is U2, V2 and W2, which I'm assuming is probably L1, L2 and L3, which is probably red, white and blue phases. I'm assuming that's the order it's in. I don't really know because I don't have the book for this drive. Obviously, to program it, you've got a panel that just clips in there normally, and you got your mains connections. That's active and neutral. We got motor brake control, which is brake positive and brake negative, and then you got the motor phases, and these are all control terminals. The drive obviously has the ability to do several different things, so let's start tearing it down. It's all clipped together. There's no real screws or anything, so if it looks messy, there you go. That little fascia sort of just come off there, not that it really matters. A bit awkward because I'm not. Let's just move this a bit closer, shall we? Now that bit's just going to fall off and stay off. All right. Okay. Well, we've got the front fascia off, and as you can see, even this is distorted because. You don't really get a very good idea on the camera, but this is sort of, pretty well at a 90-degree angle, whereas this isn't. That should be more sort of in like that. So it's gotten really hot. I don't know why, but this thing's gotten very, very hot now. Got a couple of, it's a bit of a funny angle. See if I can. Okay, well we've gotten that front panel off. It's actually, you can see that's that's distorted there. See, that's sort of not bad there, but this side's it's obviously supposed to be in like that, more of a 90-degree angle, so it's been really hot. and I've no idea why, but it looks to me like most of the heat's been concentrated in this area here. So we've got a couple of screws here, and let's see what we can remove. This is in frame, yeah. This drive's not being repaired and not being put back together, so I've no doubt that if you replace enough bits you could probably fix it, assuming there's nothing catastrophically wrong with it, but it's not worth it. For what you can buy one for, it would cost as much to fix it as it would to just get another drive. Now, I'm not really sure what's going on here. I'm assuming that there isn't a real lot holding this board on. Yep, here we go, it starts coming out. It's going to just have a plug of some sort holding it to the actual main board. I'm assuming there shouldn't be anything really much holding it in. It's just got a header on the board without completely stuffing it. So there you go. It's got like just a connector there. You know, it's nothing really special. It kind of reminds me of what IDE hard drives used to now, what interests me a lot, what I noticed, is that this drive seems to have, I'm assuming something's been inside it, like spilt on it, or I don't know. It's been wet at one stage, because if you look inside there, if it'll ever focus, maybe get the screwdriver to point, it's got like a green substance over these ICs, so I don't know if that's significant. It may or may not really mean anything, like sort of. So that may well have, I mean, this board's obviously been dipped in or sprayed with some kind of resin, so you wouldn't really expect anything to have gone horribly wrong, but something's eaten the resin. So that's very interesting. I will attempt to decipher the type number on this IC and look it up, because it's very interesting. It's definitely had something spill in there. It's not just rain or whatever, because this is like what you'd call a potted board. Like it's not exactly potted, but it's definitely got a coating of resin on the board there, and yeah, it's very interesting that it's happened in that way. Just have a look in here. Nothing really earth-shattering. You know, you got a couple of transformers or coils or whatever. 2008. There's the date code on the board down in there. Probably, well, I haven't got a hope in hell of seeing it, but that's what that is there. The date code 2008. Alright, let's pull it down further. Okay, well, we've gotten this cover off. Like I said, it just clips off, so that's obviously a grounded, you know, like it says, chassis ground, which is, you know, earthed metal chassis, I'm assuming, and VAR. Not sure what that stands for, but on the chassis it's just got ground 1 and ground 2, and I'm not sure if they're both going to the same. By the looks of things, you need a Torx bit to get the rest of it undone, so I'll go down and get a Torx bit. Okay, I found a Torx driver, not exactly the one I wanted, but it works. $10 kit from the supermarket, so it's also got a set of dual screwdrivers and this set of, you know, little screwdriver bits. So, which includes a couple of Torx drivers, which are very handy, because often, you know, things like this, hard to get it in there because it's not the set I wanted. So the set I've got, it goes up to a T50, and it's well, hang on, I think that's how it works. The larger the number, the larger the size. Yeah, it goes up to like a T50 or whatever it is, which is a pretty big Torx driver, and they're like Allen key kind of design. So what do we got here? Well, we got what look like a couple of metal oxide varistas. I'm assuming they're for the mains input protection. We got a filter here, or choke, or whatever you want to call it, so I'm assuming that's probably for filtering purposes as well. Not really sure. I'm sure you can Google the schematics for an ABB drive. Just bent that. Who cares? No, it just unplugs anyway. What do you know about that, eh? We've got a fan here which looks very well made. Looks like a very good quality unit. Probably the best part of the drive actually. It's probably the only thing worth saving. This little fan. It's made in China, but specs on the fan in case you wanted to see it. For all the fans, these move quite a bit of air too, so it's quite a good little fan if the camera's ever going to focus again. There you go. Just a little cover for it. And just pull out these screws. This is how I normally do it. You just upend it and they'll fall out. Not all of them fall out. Anyway, let's start tearing this down more. Further, I should say. So I don't think there's anything else really holding it in. I think this is sort of it. Got all the screws out. Maybe this board is maybe this board just sort of, I don't know if it's soldered on there or not. I think it could be. Yeah, it's definitely soldered in. Shouldn't be anything holding this board in apart from the screws I just undid. Unless there's something on the other. Screws hanging around. Let's piss that off out of the way. I'm assuming that just comes out. It may or may not. It shouldn't be part of it. Yeah, there we go, it just unplugs. Very neat way of interconnecting different circuit boards. What do we got here? Why won't this come out? Well, something's going to be holding it in. It's going to zoom in. We've got this VF driver part. This is the top side of that board. The bottom board is mostly just interface with the IGBTs. I haven't pulled the thing right apart obviously, but the way it came apart, by the way, was these clip things which you got to shove a screwdriver in the slits, yeah, and then you kind of just pull them apart like that. So if you're pulling apart a drive that's an ABB, that's probably how it comes apart, and it's a bit of a trick to get off, but there you go. So it's got, looks like a couple of wire wound resistors. Can't read the value. 82 ohms, 82R, yeah, 10 watts. A little bit of sticky to hold them together. We have some caps here. I can't read the brand. Maybe zoom out a bit, might help. We got these big Riffa brand caps. They're 350 microfarads at 400 volts. There are 1, 2, 3, 4, 5 of them. As for carnage, well, I am very, very sorry to disappoint everybody, but there really isn't any carnage much. I know the drive's definitely had it. There's no real melted solder or anything. It just looks just like a normal VF drive. There's no real carnage of any kind. Surprisingly enough, there isn't really much to see on here. Be a prick to pull these heat sinks off, I can tell you that. Good if I could read a tight number without doing that. Yeah, never going to happen. It's got this green plastic stuff, the heat transfer strips. neat way of doing it. There's nothing really to see. I'm sorry to disappoint you guys, but apart from the, these caps, which are probably fine, I've got no reason to assume they're not. I don't know what reefer brand caps are. I've never really heard of them much. But like I said, that's what's in an ABB VF drive. Why it failed, I don't know. Nothing really to see in there. I'll do some more research and poking around, but yeah, apart from the obvious that this is what it is and what it does and blah blah blah, and there's no real story to tell. Except the only thing I did find, like I said before, was, if I can get it to focus, is this green stuff which is all over these ICs. It scrapes off alright, but yeah, it's all over the joint. It's sort of come in from, you can get it close up. You can see it comes in from the end there, and if it's ever going to focus. I couldn't tell you what it is, but it starts at the very tip of the board near where my finger is, and it goes all the way to this big mass IC. And I'm assuming that this is all control gear, because they're the only real ICs in the whole unit. Like, there's a couple of very minor little chips on this bottom board here, which is what you'd expect, but there's really nothing else in it. This is kind of everything. This controls the whole unit. It's got some ICs on the top side of this board here, and I'm not sure what this. I assume that red mark could mean this chip's been programmed. It's a Texas Instruments chip. I'll research some of these type numbers and post, in the description. But even down here, you can see that it's had something in there. I just don't know what. I mean, maybe the drive sat outside in the rain, but it doesn't look like it's got any evidence of ever being out in the rain. So, sorry to disappoint you all. I was expecting, some real carnage of some sort by the look of the case, but I don't know under what circumstances this thing failed. I've got no real idea at all, but other than the fact that it just doesn't work, and not very hard to figure out why, because if you look at this end case, it's really distorted. So if the camera's going to focus, that'd be nice. See, it's just really distorted. It's been very hot. Sure, it's been hot, but I couldn't tell you why. Like, looking at the IGBT modules, they look fine, but then again, looks can be deceiving. Obviously they aren't fine, and obviously they've been bloody hot, so I don't see any damage or anything that would account for that. Short of actually plugging it in, which I'm not going to. Yeah, I can't really tell you much. The only thing I could say about the fact that the case got so hot is that something started dragging a lot of current and didn't blow a fuse, or breaker I should say, because this thing hasn't got any fuses or anything. It's just probably got a thermal fuse somewhere, I would have thought, but I can't see one off the top of my head. No, I can't think of one off the top of my head. I can't really see one, so yep, sorry to disappoint you, but it's got a lot of cool stuff on there. But maybe these big caps are still in good nick, but you can buy those things online fairly cheap. So obviously electrolytic caps, as denoted by that negative symbol there, they're going to be for smoothing, I assume. Well, thanks for watching, and yeah. Okay, well, I've pulled the heat sinks off these IGBT modules and didn't bother googling these bridge rectifiers because they're not going to be that interesting. They're obviously very large. The bridge rectifiers, if you're interested, are RS250-6M. So they're just to get DC. There's a couple of other transistors that I didn't Google the type number on, and if there's one there. But these main IGBT transistors, in case you don't know, like I said before, insulated gate bipolar technology transistors. with soft recovery diode. I'm not sure what the point of that is. I didn't bother reading the entire data sheet, but they're transistors. With obviously they're very efficient, and that's what it said in the data sheet, and I believe it. And the type number is GB15B60KD, and I'm guessing there's probably less than $50 worth of components here. They're not really the hard bit to replace. These, you know, these are these are where the magic happens, but they're not the complicated bit. Like, it's the stuff that drives it. Like, this is like the equivalent of a car engine. This does the actual work. This does the control. I'm not sure how much of whatever does what, but this does most of the control. This top board here. So that board is the most critical component. If this is not stuffed, all that's rebuildable. It's got a few little ICs and things on there. Nothing that's going to be hard to get or expensive, but it's just not worth it. I mean, you know, I don't know what one of these drives is worth, but it's not going to be enough money to warrant stuffing around fixing it, and you've got to get it back together again. We've got some kick-ass heat sinks, however, which would be great for a ZVS driver. It's got these little clippy thingies, to borrow one of my sister's terminologies, to hold your little transistors on there, or whatever module you choose. So yeah, they're very, very good heat sinks. So they will definitely be going in the keep pile. I'm not just going to throw it out. I'm going to, you know, hang on to it for a while. I mean, eventually it is going to end up in the bin, but I mean, unless you get heaps and heaps of these things, you'd probably find that these IGBT transistors are probably cooked. I'm assuming what's happened is, and I don't know, I have no idea about the circumstances, but something like acid or whatever. Actually, looking at it closer, yeah, that just confirms what I believe. What I think has happened is that there's been a catastrophic failure around some of these components. Like, this has a tiny burn mark. You probably can't see that because of the focus. If I can just hold it still long enough. See that burn mark right there on that IC? I don't know what's happened, but something's gotten in there. Yeah, it's got rust and stuff on it. So something got in there. It's taken out that IC and probably not done the others any favours, but that IC's been taken out. It's just a control issue. I mean, the likelihood is it's probably fried these IGBT transistors. I don't know, but in all likelihood, a lot of this is probably fine. There's probably nothing wrong with it. It's just that this board's had some liquid of some sort enter, and I'm not sure how that would have happened, but it makes sense because this drive mounts this way up, which means that this board would sit like this in the case. Now, you got like a fan that sort of sits about there-ish kind of thing, and I'm assuming somehow that some liquid of some sort got in there, and it's obviously not liked it because it's fried that IC there. That little guy's definitely fried. It's definitely been burnt. And it's just taken out the drive. Like, a lot of it's probably okay, except the, I mean, you'd question mark over the IGBTs. Like, look, if they got hot enough to do that to the case, you know, you'd replace them. But unless you can get a control board like that you can just plug in, and I don't know if you can get the little IC. I mean, it's possible, assuming nothing else and the board got damaged. And I'm not going to bother Googling all these components like I was going to, but if I can get the type number off it, the IC that's blown up is a Texas Instruments IC, and we can scrape some of this crud off there, the lacquer, which whatever was spilt on there seems to have eaten some of the lacquer off the board. It's got a funny look about it wherever the liquid is, so just get that lacquer off there. without damaging the type number too much. We need my magnifying glass. So the type number of the little IC, sorry to drag this out everybody, is can't really tell because it's got still too much of that lacquer on there. Really the sort of thing I should have done off camera, but you guys can and girls can just suffer through this. Sorry. Let's have a look. This is the other problem, when the bits get so small you can't really read the damn type numbers on them anyway. So 81K04 I think. Funny type number, but it's definitely Texas Instruments. From the very top it's an L924 and the second line's 81K04 I think it is, so feel free to Google that IC, but it's not worth fixing. Just what's the point? You get a couple of kick-ass heat sinks with these little retainers. These link things are fairly useless, but yeah, you know, you can make jumpers out of them, I guess. Whatever. Thanks for, excuse me, watching everyone, and yeah, I got some more teardowns to do, and very, very interesting. If you wondered what you can use to create a variable frequency to drive a 3-phase motor, that's what you use. IGBTs, which are very chunky looking transistors, and I'm assuming they're capable of, well, this drive was rated at I think it was 1.5 kilowatts, so yeah, thanks for watching.